Alright, what we're going to be talking about is congruence and similarity when we're talking about transformations. And there's different rules. You'll see there's different things that happen to different shapes depending on the transformation. We've got 4 different basic transformations. We could have a translation where something's just being slid or moved in the XY direction. We could have a rotation, which means you're rotating at some sort of degrees about a certain point. We could have a dilation, which is where we have something being increased in size, either larger or smaller. And we could have a reflection, which is where we have almost a mirror image across a point or a line. What we're going to be looking at, though, is congruence and similarity with respect to dilation. Now, in order to talk about these two things, we kind of have to get an understanding of the difference between congruence and similarity. And that can really be summed up in this one statement. Congruent shapes are the same shape, same size, but they could be in different positions, orientations, or form mirror images. Basically, which means you're going to have the same shape. Now, shapes are similar if they have the same proportions, which really doesn't say anything about the shape or size, but they have to have the same proportions. So proportional sides have to be equal. And let's check this out. If we look at these two pictures, so these two pictures, they've been drawn to scale. There is obviously photo 1 is larger than photo 2. What we want to check and see and find is that ratio, or find what that dilation factor is. Best way we could do that is to take a couple different measurements on this image, compare them to each other, create a ratio, and that should give us what in fact will be our dilation factor. If I look at line AB in photo 1 and I measure it, don't have to take anything special, I just take a ruler and I measure it, I will see that it is about 8.5 millimeters. So from point A to point B, from point A to point B, I have 8.5 millimeters. Now if I take that same measurement of that same line in photo 2, line AB, in photo 2, I'll see that I have 6.25 as my measurement. Now remember, this is second photo, this is my first photo. Just a good way to denote that. So I've got 8.5 millimeters from AB up here, got 6.25 for AB down here. I'm just going to make a note of that off to the side here. So I've got my AB1 in a ratio with my AB2 would be 8.5 on top, 6.25 on the bottom. Alright, now if I get rid of these measurements and we look at something else. If I look at, let's go with line CD. So my line CD is going to be that top line, kind of the barrier, the boundary that we have going on here. So CD is going to go straight across here. CD is also going to go straight across here. If I look on the top, I've got 11.5 millimeters. On the bottom, it's going to be about 8 4/10 millimeters. So I've got CD1. It's going to give me 11.5 millimeters. Oops, I forgot my half. CD2. It's going to give me 8 8.4 millimeters. So I'll make a note of that as well. Let's call this one AB. This one is going to be my CD. So I've got 11.5 over 8.4. So I've got these two ratios. And so we've got two different lines. I've got my CD line after my dilation. I've got my AB line after my dilation. Let's do the same thing here, but instead of looking at a line, let's look at an angle. And we'll take angle B going on here. So if I look here at angle B is going to be right in here, and this swing set. The same thing on both. I've got angle 2. So looking at angle 2, looking at it, looks like it's going to be equal. The only way to find that out is to get a protractor. Now, it's going to be hard to show a protractor, but if I do, in fact, use my protractor and I find what this angle is, my measure of angle 2, it's actually going to be equal to 100 degrees and that is in both images. So what we can see right off the bat, if we're creating a ratio, we can see that our angles with our ratios are going to be congruent. Those angles are going to be the same. Now, the lines themselves, we said, looking at them, we can see they're not going to be the same, but we can come up with some sort of ratio. And that ratio allows us to kind of see this relationship going on here. So if I take this ratio, this 8.5 over 6.25, and I divide that out just to get some sort of scale factor, I'll get a 1.36. That's just my ratio. Millimeters divided by millimeters doesn't have a unit on it. So my ratio is going to be 1.36 for line AB. That means in order to get line AB in photo 2 from line AB in photo 1, I've got to divide that by a factor of 1.36. Now a good way to check my measurement here with a dilation, remember our factor should be the same, so that CD factor should be about 1.36. And if I do some math here, I've got 11.5 divided by 8.4 will give me a ratio of 1 and roughly 37 hundredths, which is pretty close for taking a hand measurement with a ruler. So you can see here this ratio is going to be the same. This dilation factor then is going to be 1.36 between photo 1 and photo 2. And what that means here is I do not have congruent measurements going on, but they are similar. Since their proportions are about equal, they are similar. And what you'll notice with dilations is you won't create a congruent image, but you will create a similar image.